Welcome to FireCAD Fire Tube Boiler design software. In this tutorial, let's design a 12 tons per hour boiler. Steam pressure is 10 bar and saturated steam boiler. It's a marine scotch boiler with 3 bars. Fuel is fuel oil number 6. Water inlet temperature is 105 degrees centigrade. Back end temperature is 150 degrees centigrade. Let us also consider Economizer as heat recovery equipment. Double click on FireCAD Fire Tube Boiler icon to start the software. As we are designing a fired boiler, we can select fired boiler option. This is the input form of the software. Let us do the data entry in this. First select units as SI. Steam capacity is 12,000 kg per hour. Steam pressure is 10 bar. Water inlet temperature is 105. And then boiler type is steam boiler. It's not a hot water boiler, it's steam boiler. Back end can be wet bag or dry bag. Let's consider wet bag design. Steam type, it can be F&A 100 degrees centigrade or actual steam. Usually for process industries, they consider F&A 100 degrees centigrade. It's nothing but equivalent evaporation. If you convert this into actual steam capacity, the 12,000 steam capacity F&A would be something like 11 tons or so, depending upon water inlet temperature. Number of passes, let us select 3. Blow down 3%. If the water quality is very good, if you are using DM plant, blowdown can be reduced to 2%. Select the fuel. There is a list of fuels available here. Let us select fuel number 6. And you are presented with basic fuel composition. We can modify this as per our requirement. Radiation loss is 0.8%, that is less than 1%. Unburnt loss, let's consider 0.5%. Unaccounted, that is also called manufacturer's margin, can be 0.5%. This is oil burner, so the excess air would be around 15%. Gross calorific value as per the database is 42,000. If you want to see the calculated value, it is 45,000. But let's stick to database value. Project name. Let this be some sample. Customer name, Bill Limited, designed by, you can give the designer's name. Let us also consider one heat recovery equipment, Economizer. It can be bed tube, fin tube or gill tube. Let us select bed tube only. These are the units of data entry. Steam capacity should be in kg per hour. Steam pressure is bar. Water temperature is in degree centigrade. Means all temperatures are in degree centigrade. Pressure is in bar. Once the data is entered, we can click on auto design to run the software. In this output form, the boiler sections are given here: furnace, second pass, third pass, and also reversal chamber. In this area, boiler performance details are given here: steam capacity, efficiency, then also section-wise gas temperatures, also fuel consumption here. Boiler capacity is 12 tons and steam pressure is 10 bar. Here, number of furnaces is 1. Furnace ID we are getting around 1217 mm. This ID is calculated based on allowable volumetric heat release rates in the furnace. Furnace length is 5100 mm. Then there is second pass with 139 tubes of 63.5 OD. Also, third pass is 127 tubes with the same 63.5 OD. Then comes the reversal chamber, one reversal chamber. The reversal chamber is a place where hot gases from furnace make a U-turn and enter second pass. Here the length is 600 mm. So the efficiency of the boiler based on GCB is 87.3 and based on NCB the efficiency is 92%. System exit temperature, because the boiler has also got one economizer. If you see this economizer section, these are economizer section details and this is economizer performance heat transfer details. So gas outlet temperature is 148 degrees centigrade. So in this section, if you see the system exit temperature is 148 degrees centigrade. Fuel consumption is coming around 725 kg per hour. So for 12 tons is 725 kg per hour. So per 1 ton it would be around 60 kg per hour. These are fuel gross calorific and net calorific values. Total pressure drop is 91 mm. This is the pressure drop across the boiler, inclusive of furnace, second pass, third pass and reversal chamber. When you are selecting FD fan, you should add burner draft loss as well as duct draft loss up to chimney. So if you consider burner draft loss of 150 mm and duct and other miscellaneous losses as 50 mm, so you can add around 200 mm and around 50 mm margin. So FD fan head should be around 350 mm, something like that. This is the total heat load of the boiler. And heat load upon efficiency gives the gross heat input, and net heat input is the, when you consider net efficiency based on NCB. If you see the furnace exit gas temperature, it is coming around 1060 degrees centigrade. Second pass exit will be 370 and third pass exit temperature will be 220 degrees centigrade. After this, the gas is entering economizer. Heating surface area is 18 meters square in the boiler, so that comes to roughly 25-26 meters square per ton of steam. Furnace volumetric heat release rate is 1.37 into 10 power 6 watts, that is 1.3 megawatt per meter cube. So if you can also customize this design. So instead of second pass 139 tubes, suppose let's first redesign furnace. Suppose instead of 1217, we can make it a round figure 1250 mm. See, the furnace exit gas temperature is 1063. Once you press the redesign, you are getting 1050 because you increase the furnace diameter. Obviously, furnace exit gas temperature is coming down by 10 degrees centigrade. Let us redesign second pass. Instead of 139 tubes, say we want to use only 130 tubes. And in the third pass, instead of 127 tubes, we want to use 120 tubes. And reversal chamber is 2012. Let us make it a round figure of 2000 mm. And press redesign to see how these changes in the design data is affecting the boiler performance. Now the boiler exit gas temperature slightly increased because we reduced the number of tubes. This is how the boiler is designed and customized. You can also change the diameter of the tube. You can change the length of the tube as per your requirement. There is also one option here called twisted tape insert. Some of the boilers are provided with twisted tape inside the tubes to increase the heat transfer inside the tubes. You can select this heat transfer enhancer factor and draft loss factor, penalty factor this is. Once you are aware of the heat transfer enhancement factor, you can add these values and see how the gas temperatures and performance of the boiler changes. For the time being, we are not using any twisted tape inserts in this. Now let's go to Economizer section. Here the boiler's exit gas temperature is 222. If you see the Economizer, here the gas inlet temperature is 222. And if you see the outlet temperature of the Economizer, it is 149 degrees. You can say 150 degrees centigrade. Economizer has got a wide of 10 and a depth of 28 with a tube length of 2500 mm. You can round this to 2500, and the duct length will be, it has to accommodate that much tube length plus return bends. So you can add another 250 mm here. And the tube diameter is 38.1. And here the gas mass velocity is 15,000. This can be increased. This will result in higher draft loss. Based on allowable draft loss, you can increase this 15,000 up to 20,000. So if you redesign this, you are getting this 15,000, draft load is 12 mm. You can further optimize this economizer by reducing the number of tubes to say, make it as 8. 8 into 65 is the duct width, which is 520 mm. Now the gas mass velocity is 18,000. This is fine. But now the gas outlet temperature is 155, whereas what we need is 150 degrees centigrade only. So you can increase the depth from 28 to 30 and redesign. This has reduced the gas temperature to 152. We need further. You can make it deep 32 and redesign. See, the gas outlet temperature is 149 degrees centigrade. Gas mass velocity also within the range. Draft loss is 22 mm, that is also within the range. When you have an economizer downstream of the boiler, you have to add this draft loss into burner head. You have to consider this draft loss also. So this is how we customize the economizer. Here the aspect ratio, if you see, 500 by 2750, even this is not a proper aspect ratio. You can reduce the length and increase the width and customize the economizer. Once this is done, you can save the file, save the project file, and say, let us give a value of sample 12 TPH and save. Future, if you want to refer this design, just open the file. All the data is available to us. You can see the report here. And the report appears in the notepad. You can print the report as per your wish. Thank you very much.